Well, hello everyone, and welcome back to Adrian's Digital Basement. I'm well on my way to rejuvenating and reviving the Macintosh Lisa 2/5 that was recently given to me. Last week I was able to test out the CPU board and the RAM board to ensure that those are actually working. That was after doing some minor repair. I'll link to the videos for part 1 and part 2 in the description below. When it comes to the two biggest casualties of the battery leakage on the Lisa, it was the I/O board and the motherboard. Well, I have some work underway, but I'm waiting for some parts that I've ordered. So in the meantime, what I want to do is I want to test out the CRT that was in the Lisa, which happens to be this one closer to me. And the thing is, I'm worried about the fact that this thing has a lot of burn-in, so I'm concerned that it's actually completely worn out. So I've actually gone ahead and gathered up this second CRT that I found in an old black and white TV. I think it might work, but to be honest, I'm not 100% sure. I think it's physically the same, but I just don't know if electrically it's going to work. So in today's video, what I want to do is I want to test out the Lisa CRT, and I want to test out this one I found in a junk television set. And I want to see if either of these have any ability to actually display a good sharp image. Obviously, the Lisa itself can't run yet, since I'm still missing parts to make that happen. So I'm going to have to use something else to do that testing. And to do that, I'm going to try using this Macintosh. Yes, this has a 9-inch CRT, but I think it should work for driving these 12-inch CRTs, and electrically it should be similar enough. So hopefully this should be a good test to see if the Lisa CRT can produce a sharp image, and perhaps this television set one can as well. I am in really short supply of white phosphor 12-inch CRTs. I have a bunch of green and amber ones, which I could install on the Lisa, but I really want to try to keep the Lisa at least visually looking correct on the outside, and that means having a white phosphor P4 phosphor CRT installed in it, which hopefully is going to be one of these two. So without further ado, let's get right to it. Before we get started, the usual caveat supply, I'm going to be working with these things powered up. That means there's going to be 10 to 12,000 volts hooked up to these, not to mention there's going to be mains voltages in the power supply of the Macintosh that I hopefully can use to test these things. So please don't work on CRTs or power supplies for that matter, anything with high voltages or mains voltage without knowing how to do so safely. Now, taking a look at these two CRTs, the Lisa one's on the right, this is the one from a television set on the left. This was just a standard 70s black and white television, total run-of-the-mill junk. The thing was in really rough shape and it was slated to be recycled, so I just sold the CRT hoping that it was going to be of decent quality. There was a ton of dirt and soot inside the TV, so it definitely was high hour. So it wasn't a low hour set, but there's no burn-in visible on the black and white TV CRT. Compared to the Lisa, there is visible burn-in. It's not super apparent when the CRT is powered down, but I can see the edges of the desktop, and using a UV flashlight, you can absolutely make out that there's an Apple logo and a menu bar and some icons on screen. They were clearly running MacWorks, which is basically running Mac OS for the Lisa, and that's why there's an Apple logo burned into the corner. That's not to say the CRT can't work. It could potentially produce a good image, but if you ever show a full white screen on something with burn-in like that, you're gonna definitely see the burn-in visible. I'd rather avoid that by trying to use a different CRT. Next, let's talk about compatibility and suitability for installation into electronics. First thing you have to consider is the size needs to be the same. Now, both of these are exactly 12 inches, so that's not gonna be a problem. But beyond that, the other issue that you have to consider are the mounting tabs. These are the 4 tabs around the corners that mount the CRT into the device you're going to be using it in. And generally, there are around 3 different ways that these things mount inside the case. One is the tabs, which this has, are towards the back of the implosion band. So this metal band on both of these is the implosion band. This helps this thing from imploding because this strong steel band keeps the CRT from being able to expand. So since the front glass is curved, if it were to try to implode, that means the outer edge of the CRT would need to grow a little bit to make room for that curved front glass to flatten out. Well, this implosion band prevents that from happening by keeping everything under tension. So this band is absolutely a critical safety component, and you would never want to say cut this off if you were trying to modify this to change the tab orientation. And one of the reasons why you might consider trying to modify the implosion band is because you might get one where the tabs are in the wrong position. They might be towards the front edge. And that means, of course, if you try to install a CRT into the Lisa, which needs it on the back edge, the whole CRT will be set backwards in the case, that distance difference between the tab location. Besides the size and the mounting tabs, one of the other things that can be different from one CRT to another is the curvature of the front glass. The thing is, I found that stuff that's all from the late 70s into the early 80s, all basically interchangeable with each other. And it's really monochrome CRTs from the 90s where you start to get a flatter front glass that isn't going to fit if you try to put it inside the Lisa. If it did physically mount, you would have a gap around the bezel where the front glass was a different curvature. Not to mention, I think like the deflection angle might be different, so yoke compatibility might be an issue. But generally for stuff that's all from the late 70s and into the 80s, it's all pretty much the same. The next thing when it comes to compatibility you have to consider is the electrical compatibility of the CRTs. There's also the connector itself where the neck board is connecting up, or the connector connects up to power the cathode and the grids and the heater. Again, I found that generally, this stuff from the same time period is all pretty much compatible. These CRTs are going to run with a 12-volt filament. And while some of the grid voltages might be different, a lot of machines, like the Macintosh at least, has a very wide variability for the grids that it can drive. Now, I have a video on the main channel where I previously tried to swap a monochrome CRT into the Sorek terminal, and the one that I initially put into that terminal initially did not work, and that's because the drive electronics for the Sorek expected a CRT with a screen voltage around 230 volts, and the CRT that I found and put in, which I think was a green or an amber one, had a screen voltage of like 500 volts. So when I powered it up, nothing bad happened, it just had no image. I had to find another CRT that had a similar screen voltage of around 200 something volts just because the adjustability was very low, and that worked. But I know on the Macintoshes, you can turn the screen voltage all the way up to like 650 volts. So generally that means you have very wide compatibility between CRTs. So that means that generally the power supply and driver board in the Mac can drive a very wide range of CRTs. It's very flexible because of the screen voltage range. Now I hear people saying right now, hey, how is this going to work? The Macintosh uses a 9-inch CRT and these are 12-inch CRTs. How exactly am I going to drive one of these with a Macintosh? It's a different size CRT. It's just not going to work. Well, yeah, physically I can't put a 12-inch CRT into a Macintosh. That's obviously not going to work. But you might be surprised to find out that electrically 9-inch CRTs and these 12-inch CRTs used in these monochrome applications are extremely similar. So much so that the geometry of how the deflection yoke mounts up is the same between these two, and everything electrically is basically the same as well, except for like the screen voltage stuff that might be different. Heater voltage is going to be the same. It's all pretty much going to be the same. One difference is that the high voltage that required for these 12-inch CRTs should be around 12,000, 13,000 volts or so. It's usually about 1,000 volts per inch for monochrome CRTs. And technically you might want to run one of these at like 9 to 10,000 volts. But I think the Macintosh runs its CRT at around 11,000 volts. And that means that it should be absolutely fine for these larger CRTs. All I'm going to have to do is transfer over the Macintosh deflection yoke, which here is one from a Macintosh Classic. So this actually should work with the machine I'm about to test with. And I just need to slide this over the 12-inch CRT and get that hooked up. And theoretically, it should work. I have one more trick up my sleeve when it comes to working with CRTs, and it's this. This is my Koenig TR850 CRT tester / analyzer / rejuvenator. This thing can tell us at least what the emissions are on these two CRTs, and theoretically I could try to rejuvenate CRTs, although I've had extremely bad luck with this tester when it comes to rejuvenation, and it seems to always make everything worse. So I pretty much only use that feature of this device if the CRT is in such bad shape that it is pretty much a lost cause, and I'm going to recycle it anyways. I think what I want to do first, because both these 12-inch CRTs are totally unknown to me, is I want to get the analyzer hooked up to both of these. And I'm going to take a look at what the emissions are, see if there's any shorts, see if there's any problems with these, at least on the analyzer, and then we'll go from there and then test them on the Macintosh. All right, I'm going to get set up. Whenever you use these CRT testers, you need to use an adapter to plug into the particular CRT that you're testing. And just to show how ubiquitous these monochrome CRTs are and the connections, the adapter is labeled A1. So it's the very first adapter, and that's the one that works on pretty much all of these monochrome CRTs. First, I'll start with the CRT from the black and white TV. And actually, you might have noticed, by the way, one thing that's different about these is while I think they're physically the same size and they should both work, the high voltage anode connection on the one for the Lisa is on the top and the one for the black and white TV is on the side. If anyone watching happens to know what the difference is between the location of the high voltage anode connection, let me know, but I think it doesn't really matter as long as the connection from the flyback can reach, you're good. Right, so this thing is turned on, the power light is on, and I currently have it set for 12 volts for the heater, and I can see on the TV CRT, the heater is currently glowing, so that's working. And I have the mode selection set for shorts. So if there are any shorts on any of the grids on here, focused, G1, G2, or red, since this is a monochrome CRT, shows up as red. If any of these are lit, that means that there's internal short inside the CRT, and there currently aren't. There is a way to potentially remove shorts if that is a problem. You can set this setting and push this button and it potentially blast those away by putting high voltage into them. But we don't need to do that because there currently are no shorts. Next, I'm going to set the cutoff. And cutoff is this control. And you basically need to adjust it until this needle is just lifted off the stop. And there's a little mark for cutoff. You're not going to be able to tell on the camera just because you got to look straight down onto that meter to set it properly. A couple things you might need to worry about is the cutoff set voltage, either 300 volts or 600 volts. And there's also a G1 bias control that has to do with the cutoff. Currently we're set for -50 and -300. And I'm noticing when I turn the knob, there is actual cutoff, so that means the CRT is working. If you have no cutoff, it means the CRT is very worn out. All right, so that's adjusted where cutoff's in the right position. All right, let's try emissions test. Hey, there are emissions. We're reading an emissions of 1.0. Now the thing is, sometimes what can happen, and I'm just gonna turn that off, I'm gonna put it back to shorts. Sometimes what can happen when the CRT hasn't been used in a long time, I mean 20, 30 years, 40 years potentially, the cathode can actually kind of be asleep. I don't really know what the mechanism is for that, but I found that what can happen is just letting this thing run with a heater for a while, say an hour, the emissions can actually come up a little bit. It doesn't happen every time, but it does feel like when it hasn't been used in a long time, just letting the heater sort of warm up the entire assembly seems to kind of bring it back to life. Now, what you don't want to do with these testers, if you have one of these, is you don't want to leave it on emissions test, because that is just driving the cathode full open. It's like slamming the cathode, which is what generates the electron beam that lights up the phosphor. It's driving that at maximum potential. And that potentially, if you leave that for hours, could actually wear it out. So what you want to do is let it run with the heater running, like on the short setting, or this one actually has a G1 variable setting. You can actually set the cathode voltage between -100 volts all the way to 0. Now, if I turn it all the way to 0, the emissions, oh, it's actually over 1 now. So, but that's maximum driving of the cathode. So I'm going to turn it down to -100 and just let it sit there. And I'm going to let it sit, just sort of bake for a while. And we'll come back and we'll see if the emissions have improved even more. But I'm saying that 1.0 emissions, or a little bit higher now, is pretty good. And we have cutoff as well. So I think this should produce a decent image, this black and white TV one at least. Right, the CRT's been baking about 20 minutes. Let's see what the emissions are now. Right, so I'm on G1 variable. Let's see what this goes up to now. Oh yeah. So we're at about 1.1 now, good solid 1.1. It has improved even further. One thing we can also do is turn on emissions test, so it's at 1.1, and I'll hold down the life test button, which I think reduces the voltage of the filament. And yeah, the filament is a little dimmer now, and the emissions are still looking really good. So that's awesome. If that drops dramatically, that means the CRT is pretty worn out. So what I like to do is just write that on here. So I'm going to write emissions 1.1. Also, I have a feeling that the grid voltage on this particular CRT is pretty low. In other words, I think it's like the 280, 300 volts. That might be the difference between the top mount anode and the side. We'll see if this one works set to 300 volts, because there's a setting on here for 300 or 600 volts. If this thing doesn't really have any emissions unless I turn it up to 600 volts, then that might be the difference between this. So I just wrote 300 volts on the side there. And I was gonna say, let's switch over to the Lisa CRT. But the weird thing is actually, it has this little plastic spacer that the other one doesn't have. And this adapter doesn't fit over it. All right, so I happen to have another one, and this has a different connector. Does this one work on here? Oh, this one does work on here. Interesting. Does this work on there though? Yes, this connector also fits on this CRT. So this is the A1 adapter. You can see that center hole. And this one, the one on the left, is the one that actually fits over the Lisa CRT, and it has a little notch on there. As far as I can tell, the spacing of the actual pins is the same between both of these. It's really just that center hole is a bit larger and it has a notch on this one. I was going to say that I think that might cause a problem for testing with the Macintosh, but it looks like the Macintosh connector on the Mac Classic at least has the notch and the larger hole. Yeah, the Macintosh neckboard does slide on there without any issue. Well, today I learned there's a little spacer on some CRTs to prevent you from using this A1 adapter, and I guess that's why I made this at some point in the past. So to use my little custom adapters, I have this A4 one that's been modified, and the wires come out and go to these connectors, and then it allows me to use various sockets that I've taken off of scrap televisions. This happens to be one for color TV, and you can see that I made all the connectors the same between all my little adapters, so I can use these all with the CRT tester without having to go search for the actual sockets, which are expensive and or unobtainable at this point. And just like that, custom adapter is connected up to the Lisa CRT. I'm going to set it to the shorts mode and 12 volts, putting dirty fingerprints on this, and we'll turn this on. I can see the filament is lit. It's interesting is it's much dimmer on this CRT than it is on the TV one. I think CRTs designed for computers and long runtime use something called a dark cathode. It just doesn't light up as brightly as it does on the earlier ones, which had a much brighter little filament in there. I think it just means that the longevity of this tube is longer. Good thing is the filament is glowing, so it's not open or broken. And on the tester, we don't have any shorts lit up. Now, the focus grid is not connected. That's actually an extra wire that I didn't wire up to my custom adapter, but G1 and G2 are connected along with the cathode. So none of those are shorted together, which is good. Now this is currently set with a 300 volt cutoff, which might not be enough to produce any emissions on the Lisa CRT. It might need 600 volts, which is the other setting there. So I'm going to set this to cutoff, and I'm going to see if we get any cutoff at all. And no, the needle doesn't move at all. Set to 300 volts, set to 600 volts, doesn't move either. Wow. Well, there could be a problem with the wiring on my connector, so I could probably move it back to the other CRT, but let's just quickly do an emissions test. Oh, there is emissions, but there's not any cutoff. Interesting. Let's change the bias to 50 volts. Yeah, and even with it set for negative 50 volt G1 bias, I mean, that needle doesn't move at all. Nothing happens when I turn the cutoff here. So currently with that CRT, at least not having baked, because who knows, probably hasn't been used in 30 years or so. Yeah, there's no cutoff. And here's what I was talking about with the 300 volts versus 600 volts. So we're on emissions test at 300 volts and the needle's not doing anything. But if I move to 600 volts, at least there's something. There's some kind of emissions. But I think this CRT is going to produce a pretty poor image. So here's what I'm talking about. If I go to emissions test, watch. So the needle goes up, drops fairly quickly. And let's push the life test button. That doesn't really seem to do anything. It's just dropping. But yeah, emissions test, very bad. So I'm going to set this to G1 variable, negative 100 volts, and we're going to let this bake a while. Maybe this dark cathode takes longer to warm up as well. So I'm just going to let this sit here for 30 minutes, maybe an hour, and we'll see what happens. Right, it's been sitting here for a while, baking on G1 variable, set to negative 100 volts. Everything is set to maximum, so the emissions are going to be the best possible. And let's see what happens when we turn this up. Okay, so it went over 0.5 for a second and then immediately dropped. Now we're at around 0.3 and still falling, 0.25 or so. I'm pretty sure based on what I'm seeing here, just because I've seen a lot of these things before, this CRT is wasted. It is absolutely wasted. And that actually goes hand in hand with the burn-in we're seeing on here. And yeah, I spent a second just to clean some of the dust off here, by the way. To get that amount of burn-in on a computer that has a built-in screensaver, this thing must have been used so much. And CRTs are consumable items, especially the phosphor, wears out as it's used, it gets dim, but also the cathode does get used up as well, the emissive material that's inside of here. I think the CRT was just super well used. Now, the fact that there is no good cutoff doesn't mean this is not going to produce an image. I think it still will. One thing we have going for us, though, when it comes to this CRT, if this is the only one that can work in Lisa, is that the fact that it's only displaying full white or full black, there's no grayscale on the Lisa, or the Macintosh for that matter, means that the lack of cutoff and stuff that we're seeing here is going to make less of a difference. The fact that there's no cutoff means that the grayscale performance of this will be horrible when hooked up to something that's going to produce grayscale like a regular video image. But the 1-bit pixel display on these old computers, it doesn't need those grayscales. So it's actually going to be a little bit better, a little bit more usable in that case. But I'm going to write that the emissions we're getting is 0.25 with, I'm going to write a down arrow to say that it's falling. And I'm also going to add that it's a 600 volt CRT, the cutoff voltage that is. So it is different between these two. The Macintosh is no problem because I can just turn the grid way down to make this one work properly. Otherwise it's going to be super bright, way too bright. Hopefully the Lisa has a similar control. Otherwise this is not going to be suitable for use in the Lisa. Now, one thing people might be saying is that, hey, I'm using a different adapter here, so I've just turned off the tester. Let's move this adapter back over to this CRT and just make sure that it's still performing the same when it comes to the emissions of 1.1 that we were getting before. So the adapter is reconnected. This thing is off right now. I'm going to set it back to 300 volts. I'm going to set it to 70, same settings we had before. Turn the cutoff all the way down. Turn this on. And yes, the filament is glowing now, so that looks good. Let me see if we set it to cutoff. Do I have the cutoff we expect? Yes, cutoff is still working just no problem. Let me just make sure it's set correctly. Yes, it is. There it is. And we'll do emissions test. And yep, it's over 1. So definitely it's not the adapter that was causing this CRT to look really bad on the tester. It is absolutely the CRT itself. So that means I am done with the tester for now, unless we're going to try to rejuvenate the Lisa CRT. But first we need to test these on the Macintosh and see how they both perform before I try to do anything like that. Okay, well, we have 2 CRTs and a Macintosh here that I want to test with, and to use the Macintosh to test these, I have to fully disassemble this because obviously I can't mount these inside the computer, and I need to hook the deflection yoke from the Mac along with the power supply, and the motherboard and everything needs to be connected together. So I'm going to have to splay the Mac onto the bench to be able to drive these. So I'm going to just take a moment to get all set up, and we'll start with the television one. Welcome to Sketchville. Nothing is powered up or turned on yet. This is how I have it all set up. So obviously the power supply CRT driver sitting on the desk. Luckily there's a plastic card on the back side, so it's not going to short out to anything on the table. Everything is connected to the CRT, including the yoke from the Mac Classic. The motherboard is sitting off to the side. One thing to consider with this, the television CRT, is I noticed the DAG does not go under the implosion band. That is the case on a lot of CRTs. In fact, the Lisa one is like that. So this matte surface black paint goes underneath this band, and that means that when you connect something like the ground lead from the neck board to the corners, to the tabs, it's actually grounded to the CRT. But on this one, that's not the case because the paint stops and doesn't go underneath it. So I went and grabbed this thing, which is actually bolted onto this mounting tab, and it actually has, if I remove this clip here, there are little fingers that are touching the DAG, this matte paint. That connects the DAG, or the ground of the CRT capacitor, to the implosion band and the mounting tabs. And this thick clip lead is what's connected to the neck board, the ground point. And that's because the original cable that comes off of that, it's over on the other side over here. It's not long enough to reach these mounting tabs because it's designed for a 9-inch CRT. So I'm using both this yellow clip lead and this green one, which both make their way back to the ground strap that's sitting off to the side over here. Sorry, you just can't see it, but it's over on this side, and that makes its way over to the neck board, which completes the circuit, because remember, the high voltage goes in and the DAG is the negative side of the capacitor, and it all needs to be connected together for the CRT to work properly. The original black and white TV, when it came to the DAG ground, had this little thing attached to it. This was bolted onto one of the ears and it touched there, and that just connected, again, the mounting tabs to the DAG. But I'm using this better thing, which has these little fingers. I think it makes a better connection than that thing does. And over on this side, here's the ground lead coming from the neck board with the clip leads connected to it. And just want to make sure everything looks good. High voltage is connected, the yoke is in place, power is connected, although it's turned off to the main power supply. Logic board is good to go, neck board is connected. And the last thing I did is I turned down these 2 controls to minimum. One is the screen control, one is the focus control. These are these large high voltage pots here. and I put them to minimum, and I assume we're going to turn this on. We have no image, and then I'll have to turn up the screen control so we can start to see an image on the CRT. That's if all things work. But I think we are good to go for testing. So let's just make sure this is set to on. Okay, it is. And I'm going to use this power switch to turn it on, because if something goes wrong, I can quickly turn it off without having to reach my hands into the beast, into the mouth of the beast. Because this obviously is pretty dangerous. We have mains voltages, high voltage, all sorts of stuff. So yeah, don't do this. But here we go, 3, 2, 1. Okay, there's the chime from the Mac. I heard high voltage come up on the CRT. Oh, okay, so it's way too bright there. So I'm going to set both of those controls to the midpoint, and let's see if that makes a difference. Maybe they're backwards, where you turn it down and it makes it brighter. We'll know pretty quickly here once this warms up. Nope, still super duper bright. I think what I'm going to have to do is turn it on to see which of these controls is the screen control, and it's possible that it's impossible to set it low enough for this particular CRT. I'm going to turn this back on, and we'll see what I can do here. Oh, wait a second. Ah, yes, there we go. Okay. So I was able to set this appropriately. And there it is. The system has booted up. System 6.08L. That's the version that works on the Mac Classic 2. So we have a couple issues here. One is that it's not very sharp. Now I have full control of the brightness here. That's a Mac Classic thing. And when you turn this down, it's decent. It's decent. But when we turn this up, it gets really quite soft. And I think that's actually a wear issue in the CRT itself. I don't think that's a control or a setting issue on the board itself. I think it's just this CRT is just actually kind of worn out. Even though the emissions looked pretty good, I think that this is actually quite worn out. When I turn the screen brightness way down, I know in the camera it looks better than it is. It's pretty dim. I can see the pixels that make up the checkerboard background pattern, and overall it looks very readable. But otherwise, it's not looking super great. Now, one of the things to consider is that maybe the high voltage is insufficient to produce a really bright image with the Macintosh power supply. Like maybe it's only giving this thing 9,000 volts, and ideally this should have more like 12,000 volts, which I'm sure the power supply on the Lisa will actually give this thing. Low high voltage can result in a dimmer image, which could be what we're seeing here. There is a focus control on the back as well, and I have it set all the way to one side. I don't know if that's a high voltage or low voltage going to the focus grid. With the screen set to the minimum brightness, I can see the scan lines, and the focus control is a lot easier to set that way. And currently, it's as sharp as it can get with it set to the absolute minimum. But as soon as you turn this up, it gets very soft as it starts to kind of saturate and overload the CRT. We have to remember that CRTs are analog devices, so they can be overdriven, and that can result in softness and blooming and other issues like that. I'm just going to turn the machine off, and I want to test the high voltage using my high voltage probe. So currently the probe is touching the high voltage anode connection. Let me turn on the power. You know what? This is not the most accurate device, but I think we're actually getting around probably 10.5 kilovolts. 11 kilovolts, something like that. A bit more than I thought. Well, so what do I think about this CRT? While the emissions look good on the tester, it produces a very, very soft image. Now, is this something to do with the fact that this was from a television? Maybe, but I have a feeling this CRT is actually just more worn out than I thought it was. I think with the tester, the problem is the emission reading is very relative to like the same CRT. So a brand new one of these exact models of CRT might have read a 2.0 or off the chart, like it might have pegged the needle. This worn out version is showing 1.1 or whatever it was getting, and I think that's just not that good because the image it was producing here was kind of soft. And while it was fine and sharp when I turned down the brightness, when I turned up the brightness to make it usable, it just looked pretty terrible. If this were inside the Lisa, I think it would be pretty terrible image. So therefore, I don't think this is really a very suitable CRT for that machine. So let me swap over to the actual Lisa CRT and let's see what that one looks like hooked up to the Macintosh. Okay, this is the Lisa CRT transferred over. Everything is hooked up. I have the clip leads connected. I don't need that thing with the fingers because the DAG on this goes all the way to the front edge of the CRT. So it goes under the implosion band, meaning that the implosion band has a connection to the DAG without the need for that fingers. And I can see there's a little clip on the edge of the implosion band that loops around the tape. There's a layer of tape that's under the implosion band, but there's a copper band that loops under that makes that connection. So you don't need the fingers, you can just hook up the clip leads, or ideally you want to hook the ground lead directly to the ear, but it doesn't reach. So we're going to go with the way it is here. I think when we turn this on, we will have no image because the screen voltage is way too low, because the other one was needing like that 280 volts or whatever, and this is probably more like 550 volts. But let's see what happens. 3, 2, 1. Okay, we have high voltage. I can hear that running. And as I thought, we have nothing on screen. And if we turn up the screen voltage, there, the image is starting to appear. All right, obviously it's quite crooked here. Let's straighten the yoke out. Let's check our brightness out. Oh boy, it's maxed out. And I just played around with the settings on the analog board and everything is maxed out. So screen voltage is as high as it can go. It's probably like 600 volts. This is what we're getting. There is a brightness control on the Mac Classic, but it only actually affects when you're down in the lower ranges of this brightness control. So if I turn it down, you don't see an image right now. Now I can turn this little potentiometer and you notice how the image actually comes in there. So that's only affecting the lower ranges. If you turn that all the way up, that's just driving the cathode as hard as possible. And the screen voltage is as high as possible. And this is kind of what I assumed we would be seeing, a really, really dim image. And personally, I'm not convinced that this would be any brighter hooked up to the Lisa. I think this is going to produce a similarly dim image on the Lisa. Although a positive of the Lisa CRT compared to the other one, it's much sharper. Even at this dim level, I could say that the image that we're getting here is way, way sharper. Now I can see the burn-in on the menu bar here. I can see the Lisa didn't have as much deflection as this Mac, and the menu ended around there, and it looks dimmer in that area than this part in the border that was never actually used on the Lisa. But we can tell that the cathode emissions on this are pretty weak. And that has me wondering, maybe I need to try to rejuvenate this. It's always dangerous because if I try to rejuvenate it, could make it worse. Right now, even though it's dim, it does work and that produces an image. And it's better looking, I'm going to say, than that other CRT. But I don't know. Oh, it's very tempting. It's very, very tempting. Okay, I've come up with something, another thing to test. It's another monochrome CRT. Unfortunately, this one is not suitable because it is a 14-inch CRT, so it's too big. Even though it's monochrome, it isn't going to work in here. Now, I did write 600 volts, and the emissions were 1.3. I guess I tested it previously. But due to the size difference, obviously, this is not going to work in the Lisa. I just want to see if the Macintosh can drive any larger CRT and have it look good, like in focus, and also bright. Comparing these two CRTs side by side, I know it doesn't look like a huge difference, but it is different. The front is definitely larger on this one on the right, which is why it's not going to fit. But look how there's no mounting tabs whatsoever. So even if it were 12-inch, it wouldn't have worked inside the Lisa. Also, we can notice that the front glass is much darker on this than the other one. It looks almost black here under the studio lights, which are mostly turned off. Both clip leads are hooked onto this little copper strip that loops from the implosion band underneath the implosion band and the tape, which is connected to the DAG. Everything else is connected, high voltage, everything looks good. Okay, here we go. Okay, we have high voltage. All right, we have a very bright image, and it is paper white. And by paper white, I'm talking about the phosphor color. It's definitely a lot more yellowish than the bluish white color of the P4 phosphor common on Macintoshes and stuff like that. Let's see, right off the bat, I've never used this CRT, so I don't really know much about it. It's not very bright at all. When you turn it up, it again gets very soft. When the brightness is turned down, it's very sharp. When we turn this up, not so sharp. I'm starting to wonder now if this is a function of the Macintosh. I turned the screen voltage down quite a bit to make the raster lines go away, which is exactly the same as on that CRT from the television. And then this is a lot similar where the sharpness is there when the brightness is turned down, although this is even more sharp than the TV one. But when we turn it up, it gets very fuzzy. I did just adjust the focus control somewhere in the midpoint. It's actually much sharper now. And yes, actually, this is a very, very sharp CRT turned into the middle here, which is brighter than the Lisa one. It's super sharp, and turned up, it's a bit softer, but it's still pretty sharp. One thing about this paperweight CRT is it was donated to me as is. I don't know what its condition was in the original monitor with the original electronics, because I don't have that stuff anymore. So this might be brand new, and this is how it works when hooked up to the Macintosh, but with its original electronics might have had a nice bright image. On the other hand, it could be that this is worn out, doesn't have any burn-in, but maybe it's worn out, and that's why we're getting a dim image. It's really hard to say. I do know on the tester, the emissions were 1.3. I think that's what I wrote on the back, which is pretty good. But then we've learned that that television CRT also had high emissions, and the Lisa CRT had terrible emissions. And yet the performance of this and the CRT from the TV weren't really much better than the Lisa CRT hooked up to the Macintosh, at least. So in the end, this video has been much ado about nothing. And well, all I've learned is that, yeah, you can drive a 14-inch CRT on a Macintosh. It doesn't look super great, but it does technically work. So if you need to play around and put a Macintosh into an old TV set, theoretically you can. Even though the image is going to be kind of crappy, you could at least do it. So I think that means in the meantime, I'm not going to be doing any more work when it comes to the Lisa CRT stuff, since all of this didn't tell me anything. And I need to get the Lisa fully functional and operational, and I know there's a ton of work involved to get there. I was just trying to shortcut things a little bit and figure out if I needed a new CRT and maybe try to source one, which is why I grabbed that TV CRT. But since everything's inconclusive here, I really just need to get the Lisa up and running, and then I can test its original CRT with its original driver board, see how it performs. Maybe I'm overreacting, and even with the low emissions, it's still gonna look okay. And if it doesn't at that point, maybe I can then do the rejuvenation or try the TV CRT or try to source a different one, or, you know, figure out something at that point. But that's what I get for trying to shortcut things. I had a video pretty much about nothing. So hopefully you found some of this interesting. If you did, thumbs up. If you didn't, you know exactly what to do. I'm going to try to get to some other projects while I wait for things to come in on the Lisa, so that I can have varied content and not just Lisa, Lisa, Lisa. But at least the video today was not about Lisa specifically. It was all about having fun with these old CRTs. If you have any experience with all this swapping and stuff that I'm doing and some of these compatibility issues, please comment down below. There's a lot I don't know about CRTs, especially all the magic and the analog stuff that's going on with all the different voltages and the grids and stuff. And maybe some of those things are what are causing these not to perform well with the Mac. And I'll definitely be curious to hear more about that if you happen to know a lot more about it than I do, which is probably a lot of people that do. So there we go. Thumbs up if you like this video. Subscribe if you haven't already. Huge thanks to my supporters. Names are up beside the screen. All the usual YouTube junk. And that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.